Here we have a SAT math problem. Okay, let's go to the question. 3x negative a the whole square equals to 2x positive j times jx negative k. The given equation has infinitely many solutions where a, j and k are constants. What is the value of a? Okay, the question says this equation has infinitely many solutions. Okay, now what we can do is we can expand the square of the binomial on the left side and we can multiply the two binomials on the right side. So once you are done with this one, then we can discuss this particular information. That is the equation has infinite many solution. What can we do with this information? Okay, now let me get the expansion of the square of a binomial. Okay, for that, what I can do is I can use the algebraic identity, that is a negative b the whole square. Its expansion is a trinomial, that is a square negative 2ab positive b square. When I compare this one and this one, at the place of a we have 3x and at the place of b we have a. Now to get the expansion for this one, we have to use the trinomial we have over here, and we have to plug in this 3x for a and this a for b in this trinomial. Okay, now let me do it over here. That is 3x whole square negative 2ab. For a we have 3x and for b we have a positive b square. For b we have a, that is a square. And here we can multiply these two binomials using the FOIL method. Let's multiply the first term. So 2x times jx can be written as 2jx square. Now let me multiply the outer terms. 2x and negative k, it can be written as a negative 2kx. Now let me multiply the inner terms. Positive j times positive jx, then I'm getting positive j square x. Okay, now let's multiply the last terms. Positive j times a negative k, that is a negative jk. When I simplify this one, 3x whole square, I am getting 9x square negative. When I multiply this 2 and 3x, I am getting 6x. 6x times a is 6xa, or it can be written as 6ax positive a square equals to 2jx square. And here we find the variable x in both the terms over here. So what we can do is we can factor the variable x out. When I factor the variable x out, I am left with negative 2k in the first term and positive j square in the second term. X is factored out negative jk. Okay, after simplification, this is the equation I am getting from the given equation. And the question says the given equation has infinitely many solutions. That is, this equation is true for all real values of x. Since it is true for all real values of x, the coefficients of like terms on both sides must be equal. When I consider the coefficient of x square on the left side, that is 9. The coefficient of x square on the right side is 2j. They must be equal. And now let me compare the coefficients of x. Here the coefficient of x is negative 6a, and here the coefficient of x is negative 2k positive j square. And the constant term on the left side is a square. The constant term on the right side is negative jk. Okay, now let's solve for j in this equation. For that we have to divide both sides by 2. When I do so, this 2 will cancel out. 9 divided by 2 is 4.5. On the right side we have j. Okay, here I got the value of j. Now we can plug in this value 4.5 for j over here and here. Okay, let me do it. Negative 6a equals to negative 2k positive 4.5 the whole square. And here a square equals to a negative, for j we can plug in 4.5, that is we get negative 4.5k. Okay, now let's solve for k in terms of a in this equation. Negative 6a equals to negative 2k. When I evaluate the value of this 4.5 the whole square, its value is 20.25. Let me subtract 20.25 from both sides of this equation. Okay, let me do it. When I do so, this positive value, negative value will cancel out. I am getting negative 6a, negative 20.25 on the left side. On the right side, we have negative 2k. When I consider the terms of this equation, each term has a negative sign. Now to get the negative sign that we have for each term, we can multiply each term of this equation by negative 1. Okay, now let me continue over here. When I multiply this negative 6a by negative 1, I am getting positive 6a. And when I multiply this negative 20.25 by negative 1, I am getting positive 20.25. And here when I multiply this one by negative 1, I am getting positive 2k. Now to solve for k, let me divide each term by 2. Let me do it. Here this 2 will cancel out. When I divide 6a by 2, I am getting 3a. And here when I divide 20.25 by 2, I am getting 10.125. On the right side, we have k. Okay, here I have solved for k in terms of a. Now let me plug in this stuff for k in this equation. Then we get a square equals to negative 4.5 times for k, we can plug in the stuff, then I'm getting 3a positive 10.125. Actually, it is a quadratic equation in terms of the unknown a. Now, we can use Desmos Graphing software to solve for a in this equation. Okay, now let me go to Desmos Graphing software. Here we have a Desmos graphing calculator and I want to solve this equation for a using Desmos. Okay, when I want to solve this kind of implicit equations using Desmos, the implicit equation must contain either x or y. But in our equation, we have the unknown a. Now to solve this equation using Desmos, what I have to do is I have to use either x or y at the place of a. If I use x at the place of a, then I have to consider the x-intercept of the graph to get solution for this equation. In case I use y at the place of a, then I have to consider the y-intercept of the graph to get solution for this equation. Okay, now what I'm going to do is I'm going to consider x at the place of a. Then the given equation will become x square equals to negative 4.5 times 3x positive 10.125. Okay, here I got the graph of the equation over here, and the equation over here is a quadratic equation. When we solve a quadratic equation, we'll be getting two solutions usually. Sometimes we'll be getting only one solution, sometimes we'll be getting no solution. Okay, when I look at the graph over here, the graph intersects x-axis at only one point. So I think there is only one solution for this equation, and to get that solution, let's consider the x-intercept we have over here. So the x-intercept over here is negative 6.75 comma 0. Now to get the value of x in this equation, we have to consider the x coordinate over here, that is negative 6.75. Actually, we use x at the place of a, so the value we got over here as x coordinate is the value of a. Therefore, the value of a is negative 6.75.